Okay, so yeah, welcome to this first session on Discord. Today we're going to talk about something called RecyclerViews. But previous week you were kind of like not able to join classes, right? Because there were no classes. So I just wanted to point out here on It's Learning that I actually put up a lot of online resources in terms of online classes you can join. So for instance, if you look here under RecyclerViews today, we have this Udacity on RecyclerViews. So if you're unable to participate in the classes, you can also just try out some of these online courses. They're made by Google engineers, so they are quite good. And you can see the following weeks here. MVVM and Room is also something that has a Udacity, as well as the later classes right here. By the way, please mute your microphone, everyone. Sounds like I can still hear someone. Perfect. Okay, so just take advantage of these resources. They're quite good. Then let's get started with the actual presentation. So, RecyclerViews, whatever that is. The agenda for today is we're going to have a quick recap of what you should have learned last week. And now we didn't have any classes, so let's just see how much you gathered from that. And then we're going to talk about lists, how we can actually create lists in applications, the theory behind it, and why it's important. And then we're going to see how we can create these lists in Android using something called RecyclerView. And of course, in the end, there's going to be a lot of exercises. So after I'm done talking, I'll just stay in this classroom right here, and we will have a Q&A session. So if you have any questions, you can just ask there, and we can share screens and all these things. Okay. So, what did you learn last week? Or what should you have learned last week if you did the exercises? Pretty much what we dived into last week was all of the components that are part of the Android framework that would make it easier for you to create user interfaces and a nice user experience for the user to navigate around your application. So that could be this app bar here up in the top with the overflow menu here where they could enter settings, and they could have other buttons they could interact with, as well as back buttons up here called the up action, and this fancy little icon that basically gives you this navigation drawer. So you also learned how to implement that, the navigation drawer, as well as other UI components such as the tab layout here where you can swipe between tabs, and the button navigation, which is getting more and more popular in Android applications, and the floating action bar down in the corner as well. And some other small stuffs, like instead of using toast, you can use this thing right here called a snack bar. Also, I guess you noticed that implementing a lot of these components requires a lot of containers. So there's going to be a lot of containers around your layouts, and the layout files themselves are going to be very, very large and unmanageable. So I guess you saw, if you tried to use some of the templates in Android Studio, that they separated these layouts into multiple files using the include tag inside of Android Studio in the layouts. So you can basically merge various layouts together. And then also briefly in the last few slides, it talks about how you can actually wireframe your own applications so that you understand how it's going to look before you create it in Android Studio. Now, I know you're not user interface designers or anything, and in the industry you might just be given layouts that you should implement right away. But for the 4th semester project, and also for your solo project for Android, it's nice to be able to prototype first and use either Marvel app or the Figma tools to do that. And then also we touched briefly on material design if you did the exercises. So that's basically just understanding Google's philosophy around how an application should look and behave and feel for the user, so it's very familiar and intuitive to navigate around. And there was a lot of things in the material design guidelines in terms of how you color things, how things should animate and react when you interact with it. So this is normally where I would ask if there was any issues with the exercises, but I think we'll save that for the Q&A session after this thing right here. So if you have any questions related to both user experience or the topic for today, we are going to take it just after this 1 hour presentation. Okay, so let's get started with today's topic, which is lists. Why are lists important in applications? And that is pretty simple. It's just because they are almost in all applications and they are very central. So you can see 2 examples right here. You have a Gmail application where you can scroll through your emails, and to the left you have your Reddit application where you can actually see the news feed. But it might also be other things like a messaging application or Facebook feed or whatever. It is just very common to see lists in applications in general because it's such an easy interaction just using your thumb to scroll through things. So that's what we're going to learn how to do today. But I guess you already think that you are able to do this. So if we look at let's see here, if we look at just the normal Android Studio right here, I guess right now you would just go into the layouts, you would create a scroll view and then a linear layout inside of it, and then simply just having a lot of text views, for instance, or whatever it might be, right? And then you actually automatically have a list, as you see over here, right, that you can scroll through. So now the question is, why is this a bad idea? Why is it a bad idea to just have a linear layout with all of the text view elements inside of it? Feel free to answer in the Android text chat here if you have any suggestions to why this might be a bad idea. Yeah, and everyone please mute your mics if you haven't already. So imagine you were to create your own Facebook feed or something like that, or messaging application. Why might it be a bad idea to just create the layout like we've done right here? Yes, that's a very good reason. So it has a fixed number of elements, right? So that means if you're going to create an email application and whatnot, and then you just keep receiving emails, at some point you'll run out of views in the list, right? So the idea here is that is actually not that big of a problem, because you could just go into your Java code and then at runtime programmatically just create your text views or whatever it is and then include them in the linear layout. But that would be quite cumbersome, I agree. So if I mention performance, does any of you then maybe have an idea of why that might be a bad idea? Yeah, there's a lot of useless code, that's also true. If you have a very long list. Actually, let me show you this here. If I go to your schedule right here, and I try to click this link up here with the amount of students, then I click now, and you can see it takes at least 3 seconds to react. If I did this on a phone on my work laptop, which are so much worse than this computer I'm sitting at right now, this is basically the best of the best you get at the moment, then this will take a lot of time, and you can even see it's very choppy when I try to go through this list here, because it basically instantiates all of the students at VIA at the moment. I once did this on an old phone I had, and the phone crashed. Okay, so it's very important when you create stuff like this that your lists are actually performant. And some of the things that can go wrong, imagine that you were to create this list right here, and this list didn't only have a text view, but it also had an image view or whatnot of the students or the teachers, I don't know. Then all of these images are going to be loaded into memory, and they're also going to take up a lot of your internet connection, because you're simply going to load in all of the images as well, right? So it's both the CPU, you're going to instantiate objects, whether that being a lot of text views or image views or whatnot, but it's also the RAM, because you can run out of RAM if you have too many images or whatnot instantiated. and it's also the internet connection, right? Because you're going to use a lot of internet connection if you're going to populate all of the views that are not actually on the screen at this point in time, right? So imagine, for instance, here you can see you have a contacts application. It's only 1, 2, 3, 4, 5 contacts that you can actually see on the screen, but it would instantiate, if you have 1,000 contacts, then 1,000 text views down here, right? Or in this case, it's not only text views because there's also an image. And this is also what this guy here from Google is talking about. This is just a small promotion. This is part of the Udacity course that I mentioned previously that you can participate in if you want to for free. So the idea is we need to find a better way than just instantiating a long list of elements that we can then just populate whenever the application is created. And the way we basically do this is we use something called view recycling. So view recycling, that is basically a pattern quite similar to some of the other patterns you know already for memory management. I guess you know flyweight, and some of you have done game development might know object pooling. So this is a bit similar to object pooling in the sense that whenever a view goes off the screen here, so whenever you scroll down here and this view gets off the screen, then it would be put into a scrap pile of views here. And then whenever new views are used here up in the top, it will simply just use that view. So it reuses the views again and again. Yeah? Does that make sense to you? You can see right here, this is basically an animation that demonstrates just that. So each view have their own background color. And you can see the first 9 views on the screen are basically new views, right? But then the 10th view, that is actually the first view in the top being reused. So in that way you can save a lot of memory because you're only instantiating 9 views and then you're just reusing the same views from memory, just populating them with new data. Okay. So now that we understand this view recycling and that it saves a lot of memory and resources for the CPU whenever we start up the list, right? Because we don't have to attach on-click listeners for 1,000 elements, only for 9 or 10, right? Then we try to actually implement it in Android. And the way we can implement it in Android is with this component called RecyclerView. So this RecyclerView component is basically you can look at it as a black box that is taking care of all of the view recycling for you. In order for this RecyclerView to work, it needs to be fed some data, and that data, that is actual views that you can see on the screen. So your data source, that might be something else, most likely just an array list of strings or an array list of posts or whatever, right? And the idea then is that you have an adapter that adapts that data into views for you. And I guess you know the adapter pattern from SDJ2 already, right? It's basically just meant to convert some data into some other data that some object can use. For instance, your laptops, they're not just plugged directly into the wall. There's basically this small box, which is also an adapter that adapts the currency or the currents of your laptop from 220 to whatever voltage your laptop accepts. Yeah, in the same sense here, basically this data right here is converted into view elements that are fed to the recycler view. So our object today is primarily to create that adapter class right here. And I've basically created a small example for you that you can take and use. This is just a Pokemon list, since you know I like Pokemon. And you can find it here on GitHub with all of the code for it. I also do have made a little bit nicer version right here, you can see, where they both have the number, and you also have a background color and a nice picture right here that you can look at. And I've basically also made some other fancy stuff, like I've tried to register what color the image was to give it a nice background color. That's not part of the exercises today, but I just want to show this off. Like, this is more or less what you're going to do today. Okay, so in order to do this, so the next slide here, that's basically just kind of like monkey see, monkey do, where it's at least a step-by-step tutorial of if you follow these slides, then you can be pretty sure that you won't get stuck with the exercises. Okay. The first thing you have to do is you have to implement the RecyclerView library in your Google Gradle files, because it's an external library, and then include it in your layout. So the actual list, that is just this RecyclerView right here. We can do that right now. So if I open my Android Studio right here and then say goodbye to all these text views and also the linear layout, I guess, then we can convert this into a linear layout. And we know linear layouts need an orientation, so let's just give it to it right away. Then in here we want the recycler view. I could either go in here into the Gradle scripts and include it down here, or you can actually also just open the design view, and then up here in the corner you can directly import it. That does the exact same thing. So now the recycler view is just part of the code we can use. So I can go in here and I can write recycler view. You can see it's right here, the top one. It's part of the Android X library. And in this case, I just wanted to take up all the space, so I just use Matt's parent here. One other thing, of course, we need to refer to this in our Java code, so let's just give it an ID. I just want to call this RV or something like that. Okay, and you can see a small preview right here. It's not actually what it's going to display, but it just shows us this is a list, right? So we can go into our Java code right here, and let's just put it as a field so we can reuse it in other methods. Call it RecyclerView. And then down here, we can basically just find it as we used to. Okay. Then the next step here, that is basically to tell the recycler view how the elements should be laid out. And when I say element, I mean either a row or a column. It's just that depends on how you want to show the list, because you can tell it to be a linear layout, like that's the most common one, like I showed you here with the Pokemons, right? But it could also be a grid layout or some other kind of layout you define. Okay. And in order to do this, then the recycler view needs a layout manager. So let's just give a layout manager to it, right? So we say RecyclerView.set layout manager, and then just new linear layout manager. Now this linear layout manager needs to know about the context, and you already know that in that case you can just pass in the activity itself. Alright, one other small thing I think I mentioned in the slides as well is there is a small optimization here that is has fixed size, and that basically just tells the recycler view that all of the elements are going to be the same size, so it can optimize in some regards to make it more smooth when it scrolls. Okay. The next step then, you can see this is basically what we just did. And then it basically also adds this adapter here. And in this example, it's just Pokemon, right? So it's the Pokemon data, it adapts to views. But we don't really have this Pokemon adapter or any adapter at all. So we need to create that class, right? So you basically just go up into your Java resources, create a new Java class. And yeah, let's not do Pokemon right now. Let's do something else. Maybe posts. Yeah, post, that's fine. That is basically just imagine we were doing some, I don't know, Facebook feed or whatever. Then this adapter class right here, actually I wanted to call it post adapter, sorry. Okay, so this post adapter right here needs to extend the adapter already in this library which we imported. So this adapter is inside of the RecyclerView class. It's an inner class, so we have to specify RecyclerView dot adapter, and then it takes in a view holder, whatever that is. We'll get to that in just a second, but I'm just going to specify the view holder as an inner class of this class right here. So post adapter dot view holder. Okay, this is actually the only thing you need to know. You only need to know what to extend, that it is this adapter class right here, and then Android Studio can take care of the rest. If you just hold down Alt and press enter, it would say, well, this is this thing right here, that's an abstract class, You can see right here, abstract class adapter. So what we can do is we can just hold down Alt and press enter and then implement the methods for it. You can see there's basically 3 methods. You just press OK. We have the methods now. It's still complaining. Let's hold down Alt and press enter. We don't have the view holder class. Let's make that created for us. It still complains. Let's hold down Alt and press enter. Oh wait, the view holder needs to extend the correct class. Let's do that down here. And then you can see it still complains. Alt enter, create constructor matching super. Yes, please. So just basically by creating this one extension right here, Android Studio knew how to create all of this code for us. So that's nice. But what is all of this code doing? That's the next step, right? So let's look at the slides here. So basically, the adapter class is responsible for doing 3 things. It's responsible for creating new items in the list. So that is basically taking our XML layout file for one item in the list and converting it into an actual view element. And then it's responsible for populating the items with the data. So that means at some point in time, your adapter is going to be given your data so that it can populate the views with the correct data. And then it's also responsible for other things like returning information about how many elements there are in the list that it contains. Okay? This is basically the code I just created in Android Studio. You can see right here the 3 methods and then this view holder class. So what exactly is this view holder class and why is it important? It's actually not mandatory, or at least if you go back a few years in Android development, it wasn't. So there was another ways to create lists. And if you don't use the view holder, then you would end up with a bit of lag in your scrolling, so it would not be as smooth. And that's why it is now mandatory to use this view holder pattern. So what exactly is this view holder pattern doing? Well, the idea is that if you didn't use the view holder pattern, then the recycler view would basically give you the views whenever it was done with it, and then you would have to figure out what is inside of this view. What is the text views that I'm going to populate? What is the image view I'm going to populate? So there's going to be a lot of find view by ID calls. But if you use a view holder, then you can actually cache these views inside of this object so that you don't have to do find view by ID every time you receive a new view. That might sound a bit confusing, but let's just look at an example right here. So imagine you were to scroll through this list and you didn't use a view holder. Then for each time you would scroll to a new view, then you would have to check where is the text view and where's the image view, because there is the name for the Pokemon and there's an icon for the Pokemon, right? So that means 2 find view by ID calls. If I were to scroll through this entire list of Pokemon, and there's I guess around 900 right now, so that's 900 times 2, that's almost 2,000 times it has called find view by ID. That is a lot of find view by ID calls, and we can actually reduce that to only about 20 calls simply by using a view holder, because if we use a view holder, it can just reuse those same views that it already cast into memory. So it's only like 1, 2, 3, 4, 5, 6, 7, 8, and then maybe 2 more for smooth scrolling, right? So it's about 10 views and then times 2, so that's 20 find view by ID calls. So basically whenever you hear view holder, the only thing you should think is this is something that's used to optimize our find view by ID calls by caching the views inside of each element in the list. Okay? Good. Next step, that would basically be to create these single items in the list. So how do you want the items or the elements in the list to actually look? So we can do that just by going over here and creating a new layout resource, calling it post item or something like that. And then in this case, this is a constraint layout. I guess I like using just linear layouts. A small tip actually, if you don't want to change it here, you can also just click down here and then select convert view and then just select linear layout. And then it's done for you. It's not super clever though, because it doesn't include the orientation, so you'd have to do that. In this case, it's a horizontal layout because we want to signify how one element in the list looks. And let's just keep it very simple, so we only include a text view. And that needs a width. Let's just put that at match parent because we want it to take up the entire screen. and height could be, I don't know, let's say 70 dp or something like that. And let's give it a background color so we can actually see it. Let's just do red. Okay, so we have one element here in the list. One thing I often see students do wrong here is that they think now they can just use this list right here, but this list here actually fills up the entire screen. So that means this is one element that takes up the entire screen. So if you load this and start scrolling, then it's like one screen worth of one element. So you need to make this smaller. I guess that's easier to see if I just change the background color here as well. You can see it takes up the entire screen. You only want to take up this part of the screen, right? So you can just do this instead. And let's just put in some text, I guess, to see how it looks. Corona. And text size like that or something like that. Maybe also center it a bit. Okay. Maybe put that as 80. Oops. Okay, so we have this text view here, this one element, how we want our things to look, and then we can change the text here by simply referring to this text view. So that means we need an ID as well. I'll just call it text view. Let's call it name. So that's the name of the post, I guess. Okay, let's see here what happens here then. So this is the exact same thing, and just we have an image view as well for the Pokemon. Next thing or next step then is to make sure that this text view that we just created called name, that is cast inside of our view holder object. So we can go in here and we can basically 2 seconds. Oh yeah, okay. We go in here, and in here in the view holder we basically want to cache it, so we need to put it as a field. So text view, and let's just call it name actually, because that's what we called it before. And then in here we basically want to retrieve the view from the layout and then save it in this text field variable right here. Now we can't directly just say find view by ID because we're inside of the view holder class here. We're not inside of a fragment or an activity, so it doesn't know about that method. So we need to call it on this item view here, which is actually what we want to find. By the way, I hope you can't hear that they're like doing the mowing the lawn outside my window. I hope that's fine. So it's r.id and then .name. Okay, so that's basically all there is to it. Now whenever we have a view holder object, then we can actually use this name text view right here without doing find view by ID all the time. Okay. Next step, that is then to create an object out of that view holder class that we just created. And then we inflate the layout file that we just created and convert it from XML into Java objects. So that's what you see right here. And we can basically just copy this to go a bit faster. So basically up here, in the onCreate view holder, we are taking our layout resource, our XML file right here, and then we are converting it into a view holder object that holds our text view. Okay. And then, yeah, this is quite a given, right? SDJ1 stuff, but I guess you know that if you have very complicated list items, for instance right here there's a Pokemon with an image and a name and a number, then it's not a simple type, so it might be a good idea just to go in here, create a new object, and in this case we're just creating a post object, and then you can just specify whatever variables you have. So in this case it's private string name, right? And you can hold down Alt and then insert if you want to insert some of these things, if you want getters or setters or whatnot, or if you want a constructor you can also do that. So this is basically just a plain old Java object, a data structure that holds our name for our posts at the moment. So we could just have done an array list of strings, I guess, but this is easier. Okay. Next step then is to actually make sure that our adapter can accept the data that we create for it. So that means it needs a list of something. So in this case, it's going to be a list of posts. 2 seconds, I'm just going to close the window. I can't hear anything. Okay. So we want a list here, so that could be a list of posts, and let's just call that posts. And then we want to, whenever we construct this adapter, we want to be able to put in this list of posts. So we could say public post adapter, and then it needs a list of posts that we call posts. And this list of posts we then store in our field right there. Okay. And then we can now basically use this list of posts right here to also return the length or the size of the post. So posts dot size. Okay. And then the next step is basically to make sure in your main activity that whenever you construct the adapter, you send along whatever data you have. But that's basically what I did here as well, you can see. I just didn't use the interface. Now this is where it's interesting. This is basically the meat of the adapter. This is where it actually binds the data to your views in this onBind view holder method. And so it basically the view holder is sent along as an argument, and you can basically just access the fields you created, which in this case this would be a text view, right? So you can just call set text. And then in here you could write whatever you want, but in this case you also send along the position of the item in the list, so you know exactly what element to get, and then you can call some method on it. So in this case this would basically be, we have our view holder, in this case it's called holder, so holder dot, and then we have the name field right here, right? So name. So this is a text view, so we can just call set text. And in here we could write whatever text we want to write, but we want this to actually match the data that was given to the adapter. So we need to say posts.get and then specify the position, which would send along as well. Now this is a post object, so we need to call the getName method in this case, which is a string. Okay, hope this makes sense to you. So now we basically make sure that whenever a view needs its data, it gets the correct data in the list. And in order for this to work, we just need to go in here in the main activity and feed the adapter with some data. So let's just create the adapter first. So let's just see here, it's called post adapter, new post adapter. And this post adapter took in the list, right? So we don't have a list at the moment, so let's just create that first. So let's just see a list of posts, and that could be a new array list, for instance, right? And then we could just say post.add new post and specify a name, Corona. And then we could basically just copy this a few times and then specify, I don't know, my name, my brother. This should be fine. And then we just give the adapter the actual data, right? So posts here. And now I assume that whenever I run this code, that I should be able to see a list of items here with the 3 names. And I am not at the moment, and that's simply because I forgot one important thing. You can see this is grayed out. But we need to make sure we're actually using the adapter. So we write RecyclerView.setAdapter, and then we specify the adapter, and then we run the code again. And it goes so much faster on my desktop. That's always nice compared to sitting with my work laptop. And you can see here we have the 3 items in the list, right? So this works out perfectly. And that is actually more or less it. I think that's what's also shown in the slides here. You can see there's just a lot of Pokemon that's established here on the list. So let's see if you're actually awake and if you followed along. So this is a small quiz. And if you just open the Android text chat, I guess we can just do this, like so. and then you write, you upvote which of these you think is the correct answer. If it's recycler view, if it's the adapter, or if it's the view holder, that's the correct answer. Okay, so the first question here is, who is responsible for creating a view holder object for each recycler view item? Is that the adapter, the recycler view, or the view holder? One thinks view holder, a few thinks adapter. Yeah? More votes? Anyone thinks it's the recycler view? Might be the correct answer. Oh, okay, everyone thinks it's the adapter. That's also true. So that's basically the onCreate view holder, right? Where that is responsible for taking our XML layout and then creating the view holder objects. What about caching the views associated with each item? Who is responsible for caching the views associated with each item? Is that the adapter, the recycler view, or the view holder? Someone voted for recycler view now. Someone says view holder, yeah? And there's one upvoted on view holder as well. 2. Okay, so seems most think view holder. Yeah, a few things view holder. Yes. That is also correct. That is the only responsibility of the view holder. That is just to cache all of the views so that you don't have to do find view by ID all the time you scroll through the list. Okay. Who is then responsible for returning the number of items in the data source? Is that the adapter, recycler view, or view holder? And I can see there's more votes now for the adapter. It just goes up and up. Yes, and that is also true. So that's basically the returning the number or the size of the data source. That's basically what it's doing. What about binding data from data source to each item? Who's responsible for binding the data? Is that the recycler view, the adapter? I like how you get creative with the smileys right now. Yeah, it is the adapter as well. So what about who is responsible for recycling items so they can be used again? Now I see some activity up at the recycler view. Yes, that is the only responsibility of the recycler view, and you can basically look at it as a black box. You don't have to consider how to reuse the views. That is done for you. Great. Last question, who is responsible for inflating each item view that will be displayed? Yeah, some activity on recycler view, is that correct? Is it the recycler view, the adapter, or the view holder? Who inflates XML resources? There's some activity on the adapter just a little bit, and view holder as well. Seems like most think it's the view holder. It's a tie between adapter and view holder now. Let's see if more people join in. Is it the adapter or the view holder? I can guarantee it's one of the two. Seems like 50-50 for you guys. Okay, I'll reveal it. It is basically the adapter. So that is the method that you saw here as well, right? The post adapter right here. That is basically the onCreate view holder where you're inflating the XML layout resource to convert it into Java objects. Okay, perfect. But I guess you can almost see here, if you count these numbers here, that most of the activity and most of the responsibilities is in the adapter. So that is mostly the code you're going to work with today, what happens in the adapter. Okay, and you can see the results right here. Great. I only have one more thing to talk about, and that is actually how to create lists that are interactive. Because if you open this list right here and click on it now, nothing happens. And I guess the first response you would make to that is just to go into your main activity here, and then on the recycler view you wanted to set an onClick listener. Now unfortunately you can't just set an onClick listener on a list. That's not a feature that's implemented in Android framework at the moment. So what you need to do is you need to do this manually. Okay, I'm just going to take you through how you can do that very quickly with callbacks and interfaces. So if you go into your post adapter, then you can create an interface inside of your adapter right here. Just call it public interface whatever on list item click listener maybe. Okay. And then this interface needs to have a method that we can actually invoke whenever some item in the list is clicked. So that could be on click, I guess is very common to call it. Okay. Now we might want to also send along the number in the list that was clicked, so we can do something with it. So we could say int position here. Okay. Now the idea is that this interface right here we can implement on our main method, our main activity, sorry, so that we can invoke it from the adapter. So in here we simply just say implements and then on list item click listener right here, and then implement the method which we specified called onClick. And then the idea is that whenever we create a new post adapter, we also send along the activity itself. Because if we send along the activity itself, then the adapter can call back to the main activity and tell it that it was clicked. Okay, so that means we just need to go into the constructor here and also specify that we're using this listener right here. And we can have it out here as well, I guess. Okay. And then whenever an item is clicked in the view holder, we want to actually invoke this onClick method on the main activity, right? So we can basically do that simply by saying item view, that's the item that was passed along with the view holder, and then set onClick listener as normal, and then normally I just do this as an anonymous class, so new onClick listener right here. And this is normal like any other button presses you use to in Android, right? So in here you can basically just say listener.onClick and then pass along to position. For the adapter, there's actually this get adapter position method that returns the number in the list that we can use. So now I assume that it actually notifies this listener, which is the main activity. So this is basically just what is called a callback. It calls back to the object that created it. And then it invokes this onClick method right here. So in here we could, for instance, create a toast and then say position. So see what position that was clicked, and then just pass in the position right here. So now I expect whenever I run the application that I click it, and then you can see the position right here. So that's a very simple way to actually make your lists interactive. Okay, and that is pretty much it. I think these slides are just going through how to do exactly what I just told you. And then we get to the exercises, and that is pretty much also just following along, learning about lists and how they work, which I just presented here. And then when you get deeper in, you get to also toy around with how you can dynamically change how the lists look depending on what data they get. And you also get to toy around with other kinds of lists, or what is called adapter views. So there are other views in the Android framework which takes advantage of adapters. For instance, this thing here called a spinner, this drop down menu where you can click and then select things. The items here are also populated through an adapter, so you can toy around with creating this as well. It's a bit different from RecyclerView, but it's still very useful to know how that works. And then there's also a bonus exercise where you can toy around with various layout managers. But I think today, if you manage your time, then you can get done with the exercises within 1 or 2 hours. Okay. Are there any questions or anything? Because then I think we'll just do a Q&A session right now. And feel free now to just unmute yourself and start speaking if you have a question. Will we get the code from the lesson? The code I put here, I just created, is more or less just as good as, this is actually better. This is the same, just better. This is the Pokemon example that's on GitHub, so I'll just recommend look through that. And then as always, you remember the slides here. You can actually copy the code from the slides, so that should also help a bit. Any other questions? pretty straightforward, I guess. I will stay here on the channel for the next few hours until 4 o'clock. If you have any questions, feel free to just poke me, and then I'll share my screen or whatever is necessary, or you can share your screen. Okay? I'll close down the recording now.